So to do this problem, usually when we think about calorimetry problems, we're thinking about there's two different equations we often use. Whenever we talk about the change in temperature, that always means temperature final minus temperature initial. As we get set up, sometimes it's also useful to do a picture of some sort. A bomb calorimeter basically is a metal box then in a whole bunch of water. So all of this stuff is my bomb calorimeter. And then somewhere in all of that, there's a snack chip. That could be my chip. And I know that my chip is 2.35 grams. Something about the chip. Then everything else I know, and I know that the heat capacity of the calorimeter is 38.57 kilojoules per degree Celsius. And I know that the water temperature rose by 2.7 degrees Celsius. So I actually know that the change in temperature is this 2.7. And since this is talking about the water temperature, this is also going to be associated with the calorimeter. So that's going to give us both a heat capacity and a change in temperature of the calorimeter, since that's where the water is. It's not talking about the chip changing temperature, it's talking about the calorimeter. Because your snack chip is basically going from being a lovely little chip thing to being combusted, to being a bunch of ash. So then we want to calculate the energy in kilojoules per gram for the chip. Okay, well, all we know is about the calorimeter. We have a little bit of information about the chip, but most of what we have is about the calorimeter. So we're going to go ahead and use something that would give us information about the energy from that. So we're going to go ahead and use Q equals our heat capacity times our change in temperature. So I'm going to use that 38.57 kilojoules per degree Celsius times that change in temperature, also given. So I get a value of Q of 104.139. That's too many sig figs. Then next, so I have the amount of heat that's absorbed by the calorimeter. So that's what this number is. And what I want to know is the energy in the chip, but really just in that kilojoules per gram. So it's basically asking how much energy is contained in the chip. So this amount of energy all came from the chip. It's what's absorbed by the calorimeter, but the only reason it could be absorbed by the calorimeter is because it came from the chip. So that is my amount in kilojoules, but it asked me specifically for kilojoules per gram. So all I'm going to do to finish the problem is take my number of kilojoules and divide by my number of grams. Again, we should have three significant figures, so that is 44.3 kilojoules per gram for the snack chip. And the main thing to pay attention to here is, so since it said per gram, we just divided by the mass. Realize that in other problems, in this case we are using a snack chip, if we were using something like gasoline or candle wax or even sugar, and we gave you a molecular formula, realize that we could also do this per mole if given either that chemical formula or if we gave you that molar mass. So this does have a couple of other possibilities as you go through these calculations.